chào mừng tất cả quý vị, chúng ta đang cùng quay trở lại với Hội nghị triển vọng cơ sở hạ tầng 2019 tái định hình ngành xây dựng với phiên hội thảo 2 của chúng tôi ngày hôm nay. Và trong chủ đề này sẽ có 3 phần trình bày chính và rất mong là quý vị sẽ ở lại với chúng tôi cho đến cuối chương trình. Welcome back to the Large Infrastructure Project Conference 2019, Seminar 2 including 3 presentations, and we hope you will stay with us until the end. Và thưa quý vị, ngay sau đây, Khánh Ly xin mời tất cả quý vị, chúng ta sẽ cùng đến với phần trình bày đầu tiên của phiên hội thảo song song 2 của chúng tôi ngày hôm nay. Xin được trân trọng giới thiệu ông Marius Mavrodin, Tổng Giám đốc Sika Việt Nam sẽ mang đến cho chúng ta phần trình bày về bê tông, công nghệ in 3D. And now I would like to invite Mr. Marius Mavrodin, General Director of Sika Vietnam, come to the stage with a present about innovation in concrete 3D printing. Please welcome.
Ladies and gentlemen, good afternoon. Before I start, I would like to express my thanks to INSEE and to Mr. Philippe Richard for inviting us to participate and to present to the Large Infrastructure Conference. Number one, and I also like to thank you. I know there are competing presentations next door, and I'd like to thank you for your interest in the 3D printing technology. I'm also very cognizant that I'm standing between now and your weekend, so I will be on time, and I'm hoping to make this presentation as interesting as you think it's going to be. I had the choices on the presentation between one with a lot of data and mixed design and water cement ratio, or one with a little bit more pictures and a little bit more inspirational stuff. And I choose the one that I'm hoping at the end it will spark your imagination, it will spark your interest in the technology, and together we can move into the future. Before I start, I would like to tell you a few things about the 3D printing, not concrete 3D printing, and a little bit of history behind it. The technology was first patented in 1981 in Japan using thermoplastics. And then for the following 10 years into the 80s and early 90s, several new patents have been filled for 3D printing with methods. Different application, but obviously it's a 40-year-old technology, and it has been for the last 20 years tremendous progress. Scientists now are trying to 3D print a human heart with organic matter that can be used in transplants. So the applications of the technology is not only related to concrete and the construction industry, but also in many, many other applications. So I'm told, I don't know for sure, but 3D printing was initially developed, inspired by nature. And if you look on the screen, picture of a spider. And this is a perfect example of natural 3D printing. The spider's web, as you might or might not know, it's made of silk. And in the case of some spiders, the strength of that fiber is 6 times stronger than steel and 3 times more malleable and flexible and resistant than Kevlar. And I'm putting this up because materials that are the result of 3D printing can be extremely strong with incredible properties that other methods of construction or other methods of developing materials are not able to do. I'm going to put a couple of pictures up, and I'm going to challenge you to recognize them, and if you don't, and I'm going to the next one and go back again. This is the inside of a Gothic cathedral. You find them all over Europe in all towns. This structure has been built about 800 years ago, and it stands today, attracting millions and millions of visitors. And the next structure, which I hope you recognize as the Pantheon in Rome, Italy, has been built over 2,000 years ago. And I'm putting them up because the major objection to 3D printing is its inability to work with steel reinforcement. And yes, it's true. But I wanted to tell you that both of those structures that's standing the test of time, for 800 years, for 2,000 years, have been built with no steel reinforcement. So 3D printing, concrete 3D printing, we believe it's a viable technology, a disruptive technology that can really have a tremendous impact and has value for the construction industry for the future. The ability to build this this technology and 3D printing. It's certainly made on the back of the digitalization. And leading architects and engineers are using more and more digital innovation, BIMs, building information modeling, 3D digital design, and this technology has the ability to take those units and actually build them in a controlled environment. So we are very grateful for being able to do that, and even if it's a 40-year-old technology, it needed the information technology revolution in order to be able to become a valid technology for construction. I'm hoping everybody in the room recognizes this picture. If you don't, I'm going to share with you that this is a typical construction site. And what do we see? We do see 25, 30 people, a lot of steel reinforcement, a lot of materials from the excavation behind, and in our view, a lot of inefficiencies. And I'm going to go back and forth between this picture, but I'm going to show you this picture with a graph associated with it. McKinsey Global Institute, the smart guys analyzing global trends, have looked at the value added, gross value added, for 1 man-hour that is created in different industries and in different sectors of the economy. And if you look at the graph, the agriculture, if you take 1947, that's $100 of value added created for each hour work. It's been sitting at about 100. And over the next 60, 70 years, or the following 60 to 70 years, the agriculture has been able to improve the gross value added to $1,600 per man-hour. Other industries like retail and manufacturing has been able to increase that by 800%. And if you look at the construction industry, after some gains in the 60s, in the 70s, as buildings have become more complex and more individual, and the architects and engineers have designed more complicated, unique structures, going back to 100. And it's certainly a great opportunity to change that and create more value for each hour work. And the global trends of smart cities, Industry 4.0, the demographics, the labor shortages, and total cost of building something has increased. And the technology of concrete 3D printing has the ability to do so. You know this, I think you've seen it many, many times, and you know what they are, you know what is expected, and if I look and go back to this picture, I am hard to find anything related to Industry 4.0, and it's difficult to find too much related to Industry 3.0. So again, a great opportunity to make a change and bring construction industry in the 21st century. We know what happens if you don't change. You know what happens if you don't innovate. I believe everybody knows those companies that kind of disappeared because they didn't innovate, although they made an extremely good product, extremely popular product. But newer technologies came in and they got away. I'm showing a couple of structures that have been built using concrete 3D printing. Those structures are today in use, and it shows to a small scale yet the viability and the possibilities that can be done on concrete 3D printing in housing, different structures, and obviously fancy structures. This is not as impressive as the Gothic cathedrals in Europe, but they do have the capability of going there. I'm going to bore you with some facts and figures. I'm going to go quickly past that. My time is limited, and I'm just going to show you where the concrete 3D printing it is today. And obviously, this is not a technology for mass manufacturing. Obviously, with large mass manufacturing, the more units you produce, the unit costs go down. And in case of 3D printing, it's usually constant. But if you look at cost versus complexity, this changes a little bit. And if you take in consideration all the factors as time, take in consideration additional innovation, the market for 3D printing becomes viable and it becomes quite large. Smart guys, Credit Suisse, McKinsey, Morgan Stanley, have been looking at 3D printing, not concrete 3D printing, but 3D printing in general. And they come up with a number, $5.2 billion in 2015. And depending on who you talk to, by 2020 it could be 41 billion, 21 billion, and somewhere in between, with McKinsey going out saying that by 2025, which is not too far from now, time flies pretty can be somewhere around between 200 billion and 500 billion. No matter what number you pick, this is a significant market, this is a growing market. And if you look below, this industry already disrupting the prototype industry at the value of 12.5 billion, and it started in the 80s. And then molds and tools in the 90s is still a small penetration. But this is where concrete 3D printing is, along with other applications in non-consumer goods and consumer goods that will be able to be 3D printed and customized. If you look at our customers today in construction, customization, it's the key to success. Different customers want individual solution. One solution is not always acceptable or sufficient for the entire market. And concrete 3D printing allows operators to do just that. Customized solution for their customers. I'm going to go over that. All this says is the projections were that the macroeconomics were expected in more than 10 years from 2015, but in 2018 the concrete 3D printing technology, it's already operating and working in several countries in Europe, United States, and Asia. I'm going to put some pictures up and I'm going to let the video run. And ladies and gentlemen, this is all where the magic happens. This is the printer head. And what you see here is the printer ink. Nothing more than that. So I'm going to let it run and explain to you a little bit more of that. The key to this technology is the design of the printer head and, most importantly, the material. The mixed design and the design of the concrete 3D printing mortar. It's very precise. And the other important factor is it's done in a controlled environment. This is not on site. This is done in a factory setting, in a controlled environment. It doesn't matter of the weather, it doesn't matter of the exterior and outside conditions. You can continue to produce and then install on site. Enough of the video. There are other competing technologies, or I don't want to say competing, but adjacent technologies with concrete 3D printing that is trying really hard to automate production. This is a bricklaying machine. You can see the mortar being applied or the glue being applied and then placed. This is slow motion, by the way. And it's really, really efficient in an area where bricklayers are disappearing. Qualified bricklayers are really, really difficult to do. And take the production, again, that's down outside in the elements, into an industrial setting. I can let it run for a little bit. You could see in 30 seconds how they do a window. Although I think my time is running out pretty quickly, and I guess you get the idea. But if you're interested, I can send you this presentation. I'll be very happy to answer more questions at the end of the session. This is how the mortar is applied, and this is how the brick is done. And again, it's the drive for industrializing the construction process. I heard a couple of weeks back that an interesting company is getting into the construction business. Do you know who that is? Toyota. In Japan, apparently, there's legislation that the majority of the construction will have to be done in a controlled industrial setting, modular, 95% of the construction will have to be done through modular construction. And Toyota is taking their competencies into doing things right, into efficiencies, into the manufacturing process to start building homes and units and hotels. And that is obviously helped by the development into the technologies. I'm going quickly over that, and I hope the main idea remains that industrialization is all processes is required. This is again a short video on how units, no matter what they are, no matter what the shape they're in, are built using the concrete 3D printing technology. And again, the magic is in the head, in the production, and this is actually the printer. And right now there are printers with diameters of over 5 meters, giving a lot of flexibility in what can be built, what segments, what structures, with what elements can be built. And the speed is increasing. You look at the speeds, 1 meter per second, vertical up to 20 centimeters per minute. There's more proprietary print heads. There's a race. There's a lot of companies developing those printed heads. There's a race for developing printing motors. But what the technology offers and what's important is continuous quality. Better look at that than this and deal with my front to you. Setting on demand, industrialized design, continuous mixing, low viscosity mortars, and obviously the ability to place up to 2 tons an hour in this setting. More videos, keeping it light. So I wanted to put up how easy it is to finish, to change the finish, to choose your finish. If you choose that you can do any type of finishes. This is the spatula that I'm turning my eggs over, so it doesn't need specialized tool to do so. Those are some of my colleagues in Europe. Where does everything start? It starts in the lab. We can take the element and do a lab trial at a 1 to 10, and 1 to 100, 1 to 50 scale to validate its structural integrity. And then we can take this process and scale it up to the real sizes quite easy. And the ability to test your ideas, the abilities to do it before a small scale, seeing what it is, and then go big. It's really important. And by the way, there's a piece of 3D printed object on our booth. If you want to go and see it, touch it, you're more than welcome to do so. So you take the design, you scale it up, and it's easy to go big from small. Now, those couple of slides get me really, really excited. I'm sorry, I'm sure you guys get excited over different things, but I get excited over that, and I'll tell you why. We broke a piece out of here, and then I want to show you the piece. Now look at that. No layers, consistency, strength throughout. It's that, and although you see the layers here a little bit, look what the concrete mass look at. And I'm going to challenge you to take any cast on in place, cast on site concrete and break it up and make it look like this. The difference in vibration, difference in the slump of the concrete, difference in temperature and casting conditions really are not conducive to get anything like that. Please allow me for that. I'm an old concrete head, so gotta do that. Perfect binding and a great structure. So what is available today? This is a Sika slide. I didn't mean to turn this into an infomercial, but up to 5 meters, allowing to build quite complex structures. Patents, a number of patents have been done. Obviously, 2 tons an hour, fast setting, and really an efficient way to build anything that you want to build. So you've seen this video outside is running on our monitors, and with that, I would let it run for a couple of seconds because I still have 1 minute and 59 seconds remaining, just to show some things that can be done. Lower construction costs. Obviously, the ability to go into different markets. Precise modeling of elements. Industrialization. Color on demand. You can make this any color you want. You can add fiber to it to prevent cracking and increase durability. And obviously all in a controlled, industrialized setting. And yes, we do have some know-how into making this happen. In the interest in time, I'm just going to move forward. I hope the idea is well recognized. So, if you look at the main elements and starting with the freedom of design, the new design possibilities are there. You can customize, you can offer different solutions, customized solutions to customers, and a lot of other elements and a lot of other benefits that are with concrete 3D printing. The key to it, as I mentioned it before, and I'll mention it again before I'm ending my presentation, is the fact that you can industrialize this process, taking out from the field into a factory setting with higher productivity, more consistency, and extremely high precision in the level of customization. Where it can apply, art and design, furniture and building components, architecture and construction, all these spheres require different inks, different 3D printing motors. Obviously that's clear, but the possibilities and the applications are really endless. The other thing that Philippe mentioned is how much concrete is being used in the construction. And if you look at it, this would be a ceiling made of concrete with a certain thickness. If you use 3D printing concrete elements, you really can reduce the weight. You really can reduce the amount of material that's being used if you not have a load-bearing wall or a load-bearing roof. And you can see it a little bit here. It's beautiful. This is a case study between 3D printing technology and casting some facades elements. I'm not going to go too much in that. Just to say that if you look at the total cost of an element, the forms are almost 45% of the cost. With 3D printing, that can be eliminated, and it's much easier and less effective costly. A couple of examples of 3D printed elements that have been done. This is in front of our research and development lab in Zurich, Switzerland. And with that and the image of the surface of the element, I would like to thank you very much for your attention and really appreciate it.
Please stay on stage for Q&A session, please. Yeah. Thưa quý vị, không biết là quý vị có câu hỏi nào để gửi đến cho speakers của chúng ta không ạ? Yep, I have a question here.
Yes.
You can use this one. And the questions, English question. Where is Vietnam standing in this 3D printing application? There is have any project in Vietnam apply it? I will repeat the question for you. This is an English question.
Yeah. I can understand.
Where is Vietnam standing in this 3D printing application? Does it have any project in Vietnam apply it?
No, unfortunately no. There are not current projects or producers in Vietnam using 3D printing technology. There are a number of them in Europe, in the United States, in the Middle East. But certainly the availability of the technology is here. It is here today. There are a number of companies, including Sika, that can provide this solution to customers that are interested in getting into this business and obviously realizing the benefits that I just told you.
Yes, thank you. Và Chiếc Ly hỏi là còn ai có câu hỏi nào nữa không ạ? Do you have any question? Dạ. Xin được mời chuyển micro đến với cánh tay của anh đang đưa tay lên ạ. Xin mời anh đưa tay lại ạ. Ở phía giữa.
Thank you, Marius, for your wonderful presentation on 3D printing.
Thank you.
So I fully understand that this is the future technology and more future in the small complex units like in medical application. But in civil engineering, if we use the 3D printing, as you know, it's very costly. So that's why it cannot feasibility in Vietnam. And also the mechanical chain of 3D printing, because it's by layer. So the bottom layer, it needs to be set and mechanical property, and then we bring the other layer. So in this case, how can we deal with this problem? Thank you.
As I mentioned, the major objection to the technology is inability to work with steel reinforcement. But the strength that can be achieved with 3D printed materials, absolutely incredible. And then it needs to be a connection between the base and the substrate and obviously the structure. But to go back to the cost, and I didn't have too much time to go through the mechanics and line-by-line items, but we needed to build 168 facade units. They are completely different than everybody else's facade, because we are Sika, we want to build a building that has some individual component to it. And if you look at the cost using the traditional precast methods, which we use, cost about 7,800 Swiss francs, from which 3,400 Swiss francs were the cost of the forms. Now, it's Switzerland, might be a little bit different in Vietnam. But being able to use the 3D printing technology to build exactly the same 168 facades units for our building would have cost 60% less than by the traditional method. So right now the application has some limitation, but as this technology develops, as we can create a platform from discussion with all stakeholders, with engineers and architects, with producers, with general contractors, the technology is going to evolve. And I have no doubt that the collaboration on a really sustainable platform will bring in incredible results and a very, very fast development of the technology.
Yes, thank you. And there is the next question I will read for you also. What's the degree of complexity of 3D printing for high-rise?
It does have some complexity, but I want you to think of the high-rise as a complex matrix of units that are pretty much the same. If you bring apartments, they usually have the same layout. And you have, well, the capability with 3D printing exists to print an apartment or to print a bathroom that can be picked up and put. I didn't incorporate it in my presentation, but there's a video of a hotel being built in Singapore probably a year and a half ago, where it was a completely modular construction. Every unit, every room with the bathroom and the windows and the doors and the plumbing and the bathroom fixtures were built off-site. And then once all those units were ready, it took those guys 4 days to put that hotel together, connected, and go for the grand opening. And this is what this technology brings to the table: the ability to pre-made, pre-stage in a controlled environment, and then put those pieces all together for really, really efficient construction. So it's not that difficult.
Yes, that's all. So thank you so much for your presentation and Q&A sessions.
Thank you very much.
We give a big award for Mr. Marius Mavrodin. Thank you so much.